When we look at a course such as business, calculus, and algebra with some solid prerequisites from secondary school, we would expect that students coming into the course would have some solid foundational skills to help them be successful. What I found in many years of teaching this course is it is surprising how the calculus is never the stumbling block, but rather the foundational skills are, such as order of operations, expanding brackets, operations with fractions, rules of exponents, and fluency with decimals and fractions. So in a course which offers 2 hours per week in class, much of the time is spent looking back at foundational skills in order to move them forward. I'm going to start with a fairly straightforward function and look at how a student might come against some barriers in just taking a simple derivative. So here we have a function with 3 terms, and if I asked a student to find the derivative, they would examine what each term is, and of course they would be applying the power rule. So what I see with some regularity is students not really understanding how to work with negative numbers. And then if we start to take that derivative, we see that we have minus 16 times 3 halves, x to the 3 halves minus 1. And again, we're going to see students wondering, how do I handle this? A whole number multiplied by a fraction. And then here, of course, taking a fraction and subtracting 1 from that. And that's going to be a problem for some students. And then even the last term where we have just an x, many students wouldn't actually see that with a missing coefficient, that there's actually a 1 there, and that would end up being the derivative of that term. So here we would have issues with students sometimes not knowing what to do here. And of course here, subtracting 1, where we would subtract 1 in a fraction that has the same denominator as the fraction we're subtracting from, 3 halves minus 2 halves, and so on. Okay, so we would be able to get through that and find that the derivative is minus 24 x raised to the power of 1/2 plus 2.6 x to the 0.3 plus 1. So in fact, many students would stumble with that first step, even though they understand the concept of power rule and they've practiced it with some very simple examples. Here, some of the problems would be with negative numbers, subtracting fractions, and also multiplying a whole number and a fraction, and realizing the coefficient is 1 when none is written. Much later in the semester, when we're looking at finding equilibrium point, producers and consumers surplus, students are often faced with a supply and demand function, linear function, but with fractions involved. So here we can see that our supply function 1/2 q plus 1 and the demand function minus 3/4 q plus 16, even though the 2 fractions are fairly simple benchmark fractions, we still have students stumbling with that. So equilibrium, meaning we're going to have to set those 2 functions equal to each other and solve. The first step would be, of course, 1/2 q plus 1 is equal to minus 3/4 q plus 16. Students are then faced with collecting like terms and solving for q, but they're also, if they can get that far, we have 1/2 q plus 3/4 q is equal to 16 minus 1. Okay, so this is fairly simple, 16 minus 1. but then they're stuck here with what do we do with a half and 3/4. So here some students would see that they're benchmark fractions and they may convert them to equivalent decimals and proceed successfully, and the weaker students will simply give up. But some students who are in the middle of that spectrum will find the common denominator of 4, and they will then go on to add those two together successfully. But some, again, will be stuck here with 5/4 q. What does that mean? And how do I find q by itself? So some may take the next step where they are dividing by that fraction and then wonder, how do I proceed from there? Then we would have to find what the supply at 12, for example, would be. So 1/2 12 plus 1, and of course 6 plus 1 is 7, and we can proceed from there. If we're looking at consumer surplus, our next step would be integration. So consumer surplus can be found by integrating and evaluating from 0 to 12 of this function. And what we find here is a lot of students will be fairly successful here because 16 minus 7 is fairly simple. And even if they drop the brackets by mistake, they would still end up with this same function to integrate. But again, here's a huge stumbling block for students where they are now faced with dividing a fraction by a whole number in order to integrate. And again, some will simply get here and not really know what to do. Others may convert to a decimal and move on successfully. And some may not realize they have to integrate and simply substitute 12 into the original functions. Now, when we get to producer surplus, it causes an additional problem for students, and I'll show you why. The additional problem is students sometimes will simply drop the brackets without changing the sign here or putting that negative sign across both of those terms. And of course that introduces an error. And so some students will successfully realize that that negative sign has to go through here. And then they're able to get this far, and when asked to integrate, again, some may be faced with the concern of how do I divide that fraction minus 1/2 by 2. So you could say to students, well, you have a half of something, and then if you split it into half, you would have quarters. But they struggle really with the understanding and mechanism to do that. One last example involves E functions, and really the biggest stumbling block here is order of operations, and I'll show you what students often struggle with. So if we have this function f at x is equal to 1, 2, 3 e to the 0.25x, and we're asked to solve when x is 2. So we substitute that in successfully. This is before we would do any calculus, when we're simply just solving the original function and then looking at the rate of change or marginal function next. But what students will often do is proceed with grabbing the calculator, and they'll start 1, 2, 3 times e raised to the power of 0.25 and then times 2. So instead of following the order of operations and realizing that you are raising e to the product of 0.25 times 2, so in fact what they should be doing is, this would be your first operation where you're multiplying 0.25 times 2. Second would be raising e to that power. And the third would be multiplying by that coefficient 123. And so if the students proceed incorrectly, they are going to get an answer of 61.5. And the correct answer is 202.8. So students won't look at that number and immediately realize that it's incorrect, and they'll move on without understanding that order of operations and the importance in following those rules. So we're going to look at how these foundational skills can be remediated prior to coming into a calculus class, regardless of what the prerequisites the students have. They may not actually have the skills to be successful.